Good morning, good morning, good morning. Well, actually, it's already past lunchtime. Ladies and gentlemen, it should be a little bit morning going to afternoon. This is going to be a quick video, so make sure when you get in here, you're grabbing the staring back at me. Make sure you have compass, a protractor if necessary. Not really thinking you need one, but just in case you do, you can definitely get one. And make sure the camera didn't move, kind of, sort of. After you do this, of course, I'm gonna push Matthew because obviously we have a lot of time and I'm not here. Make sure you get that done. Make sure you do the Schoology quiz. Take care of business, don't waste time. Next time we will go over, I believe it's rotations. That's gonna be a little tricky. This is not too bad. Reflections is a good thing. Everybody did wonderful on the test. Like I said, geometry is kicking butt. Let's keep doing it. All right. Skipping the warm-up because I don't want to get too much into reflections of graphs that you did last year. I want to focus on the reflections for this year. Some key terms you should know what reflection is. Perpendicular bisector theorem. That is something that we should already know how to do. And then of course we're going to prove it. Okay. Constructing a perpendicular bisector through that line, or segment, I'm sorry. Really difficult, but we need to remember to get our protractors, our compasses. This is like when we're constructing a square. If I get my compass, I want to make sure I draw arcs that are somewhat towards the middle. Before we're only drawing one arc, but if you draw both arcs, that'll give me a much straighter line. And we should be able to construct a perfect bisector. I did it pretty fast. Of course, you can definitely rewind. I don't want to keep doing that, sorry. And we just constructed our perpendicular bisector, which is also 90 degrees. We need to make sure we're comfortable with perpendicular. Remember, a lot of us are still messing up on changing those slopes. That's gonna come into big time on Wednesday for rotations. But easy said, easy done. Boom, let's keep going. If you're not sure, rewind. Should I draw Chafita's one? Something like this, something like this, just so we can have some people there. Boom, something like that. Doesn't look too beautiful, but hey, I can't get that on the paper just like that. Let's keep rolling. Skipping those. Of course, I won't lie to you, I don't know why they have this line N, but we're reflecting JFD. Of course, make sure you label correctly. Cross from F, that's my F prime right there. J prime up here, D prime up there. You know how to do this, nothing too crazy. Is there a relationship between segment, let me do this different color. J to J, F to F, and D to D? Yes. Parallel lines, possibly same lengths, not really, we don't know all the lengths, but for sure parallel lines. And we could see that our line is straight in the middle of all our segments. Rewind that because that is interesting. Okay, skipping those. Of course, reflection is labeled as R, which takes its input P, the location of the point, with some respect to the line. The reflection L and outputs R, reflection of LP, or the opposite of the location of P with respect to the line of reflection. This is a bunch of gibberish, to be honest. They're making it way harder than it's supposed to be. Of course, I like this word right here, isometry. Don't forget this preserves the shape, basically the same thing. Make it a little more easier. Obviously on the test we had isometry on there. A lot of us missed that because we just didn't remember it stays the same. Okay. Not gonna worry about this stuff because I would love to talk about it more. This is the focus, number 5. So I am reflecting across line M using STUV. Nothing too crazy, you don't have to be beautiful. Boom, 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 boom. Not the most beautiful shape, does not look the same, but if we can keep the isometric shape, which is on the grid, you're gonna be perfectly fine. Labeling, T prime, S prime, U prime, V prime. Boom, boom. Nothing too amazing. You guys can do this easily. Another example, reflection across C using that triangle JTG, or yeah, JTG, something like this. Boom. J prime, T prime's up here, and G prime. Of course, this is where it's gonna be very important. My thing about this lesson, I didn't like it because there's no grid. I can't measure perfectly because I should know this distance should be the same to this distance. This distance should be the same to this distance, and so on. But once we get on the grid, we should be completely fine. All they want you to know is that you can reflect across anything, not just the x-axis and the y-axis. We could reflect across linear lines, probably even other stuff. Be ready. Okay. This is just a proof talking about it, saying the distance should be equal, which will form my perpendicular line. Boom, boom, boom. All the congruency that you need to know. I would definitely read about that, but I gave you the Cliff Notes version. All right, determine which figures have reflections. Let's do it. Point to point, point to point, point to point, point to point. If I found the middle part, we will have some type of line right here. This is reflection, check mark. What the French toast is this? This is not reflection. This is probably rotation. Do I know what point? Probably not. Probably rotate like that. Don't stress too much about it. And of course, this is not reflection. This is probably translation. We've been talking about these main transformations since day one. It should be already pop in our head what's happened. How do you know? Do this on your own, little reflection. Of course, here's the theorem. Gonna rush through this a little bit. Our segment RB is being perpendicular bisecting right in the middle, creating that 90-degree angle. We should know that this is the same to this, and we're gonna talk more about it. This is a perfect example. Not only did we just talk about how R and B are being cut right in half, making this point and these two sides congruent, but any point on this line will also make whatever new lines congruent as well. Obviously, we can tell, hopefully, that this is a right triangle. Two right triangles, easy done, easy set. Perfect. Provide your own reason. Okay, we're going to do another proof about perpendicular bisecting. Of course, I don't know the degrees of this angle, but bisecting means I'm cutting it straight in half. Of course, if I connect it B to A, I can construct with my compass some arcs. Not going to do something too amazing, something like this. I would do better with my compass. And if I do my beautiful line, I should be 90 degrees, which cuts this in half. So this angle should be congruent to this angle. Very cool. Talks about it right here. But it's not really explaining a lot because it's not going to be on the test, but it's for future reference. Of course, this is just another one. H to N is a reflection, midpoint. G to M is a reflection, same midpoint. J to P is a reflection, boom. My reflection line is something like that. This says to describe the transformations. Mr. Ramirez hates this because I don't know, without a grid, I need an X and a Y axis to be able to show you all that certain things are happening. I could say it's a reflection and translation up. I'm not sure, I can't tell you 100%. don't worry about those. You can probably investigate that because it has a line. That'd be pretty cool to check out. And that's it. Terrific, terrific. Of course, you know reflections already. Not gonna stress about it, not yet. Soon enough, it'll get harder and harder, but still just keep in mind, reflections can reflect over anything. If I give you a line that looks something like this, you should be able to reflect this over this. We're gonna talk more about it because of the equal distance coming across. If you have any questions, send me a remind text, send me a Schoology message, send me an email. Make sure you get the quiz done. Make sure you're doing math here. I'm gonna look at the data. If I don't see anybody moving across, that's gonna be a big issue. Y'all have a great day. See you on Wednesday.